Dr. K. S. Ramakrishnan is working as an Assistant Professor, School of Education, Tamil Nadu Open University, Chennai 15. He has been teaching science education, environmental science, educational technology and research methodology in various colleges of education and Tamil Nadu Open University for the past 9 years. He has guided so many M.Ed, M.Phil and PhD students. His current research areas are environmental education, educational technology and media and communication. He has conducted various workshops on ICT usage in education, Wiki Educator, e-content development and educational research methodology. He had attended many online workshops on Moodle, learning analytics. He has published 6 books and many articles in national and international journals of repute. He regularly gives plenary and keynote speeches on environment and ICT related issues at various national and international conferences. He has delivered 28 episodes of the program Pudiyodor Ulagam at All India Radio, Chennai, related to various new developments in science and technology.
Welcome to UGC CEC program on environmental science. In this episode, we are going to discuss about the phenomenon dispersion, and we are going to discuss about the meaning of dispersion, the quartile deviation, the calculation and interpretation of quartile deviation, the variance, standard deviation and situation where the quartile deviation, variance and standard deviation are applied, and the advantages and limitations of quartile deviation, variance and standard deviation. So, we are going to discuss about 3 phenomena: variance, quartile deviation and standard deviation. Now, let us discuss what is called dispersion. Dispersion is defined as the degree to which the numerical data tends to spread about an average value. That means, in the previous session we have discussed about the average, that means the mean, and now with respect to the mean, to what extent the data or the values they are dispersing, that is called the dispersion. That means, the central tendency is one aspect and the dispersion is just opposite to it, and it refers to the variability in size of terms and the deviations of size of terms from a measure of central tendency are averaged to give a single figure representing dispersion. That means, to what extent from the central tendency each value is deviating, that is averaged, and that particular concept is called the dispersion. And now, let us consider the data. Consider the following data set. There are 2 groups given, group A and group B, and group A, the values are like that 65, 60, something like that, and these are all the value. And as far as group B, these are all the values. And now, if you are calculating the mean, the group A and B, the median, the mode and the mid range, you can see all the values are same. But now also, if you observe the data carefully, we can say that the data set and the range, that is somewhat different from the data set B. And now, let us see what is the difference. And if you are taking the graph, now this graph is for set A and this is for set A and this is for set B. If you take the data set for set A, it is accommodating fully within 60 to 80, but on the other hand, the data set B, it is ranging from 40 to 100, and that means the variability of data set B, that is much more than the variability of data set A. And now, so the scores of B are much more widely scattered than those of group A, and the averages are not sensitive, as we have already seen. The average, the mean and all these, they are not that much sensitive to the variability, and to have a correct analysis of these 2 series, we study a good measure of the variability and the name given to this scatter is dispersion, and the range, quartile deviation and standard deviation are some measures of dispersion. That means, now we have come to a conclusion that the average is not the only measure, and beyond that, for measuring the variability we need some more measures, and the standard deviation, quartile deviation, etc., and they are providing that particular measure. And now, how to calculate the standard deviation? And the standard deviation of a population is sigma, and the sample variance and standard deviation are signified by S square and S, and the standard deviation of a sample, that is given by the formula summation over x minus x bar whole square divided by n, where x is the particular value, x bar is the average, and therefore, what this is giving, x minus x bar, that is giving the deviation, and that is squared, because the deviation may be positive as well as negative, and therefore, that deviation is squared, and that is summed up. And if you are taking the average, then that particular term is called the variance. For example, if you take this particular term alone, that means summation of x minus x bar whole square divided by n, and that particular term alone, that is called the variance. If we are taking the square root, then that is called the standard deviation. There is not much difference between the standard deviation and variance, both are meaning the same thing, but one is the square and another is a square root. And therefore, by using this formula, that we can find out the standard deviation. Now, what are the steps in calculating the standard deviation? We have to find out the arithmetic average of the series and find the deviations of each item from arithmetic mean. Let us denote by D, and square the deviations and total them. Let it be summation of D square, and divide the summation D square by the number of items. This is called the variance, and the square root of the variance is called the standard deviation. Now, let us take a practical example. Some data set is given, and first let us take an ungrouped data, and the days absent and the number of students. So, the days absent 6, 7, 8, 9 and so forth, and in each days absent how many number of students? That means, 3 students were absent for 6 days, 6 students were absent for 7 days, and like that. So, it is an ungrouped data. Now, how to calculate the standard deviation? And here we are tabulating it, and here the days absent we take it as x and their corresponding frequency, and here the product of f into x, that means 3 into 6, 18, something like that. And the deviation, in the previous episode we have discussed how to calculate the mean by the method, and therefore, here that we are assigning that 0 for this class, and therefore, all that above -1, -2, -3 and below 1, 2 and 3, and these are all the deviation and the square of the deviation and f and d square. So, here that we have summed up the total number of frequency, that is 48, summation of f x and summation of f into d square. So, all that we have tabulated and calculated, and now we have to put into the formula. And now, what is the formula? Summation over f d square by n square root, and that is equal to the summation of f into d square, that is 124 by n 48, and therefore, that is giving you 1.6, and therefore, the standard deviation of this data set is equal to 1.6. So, what does it physically mean? From the average, the values are deviating on both sides to an extent of 1.6. So, for example, the same data set if you are taking, and if you are finding the average, that means with respect to the average the data points are moving 1.6 on the right side and 1.6 on the left side. That is the meaning of standard deviation. And now if the grouped data is given, so here as an example the age and the number of employees and 20 to 25, 25 to 30 etc. and the number of employees. So, it is a grouped data. If it is given, how to calculate the standard deviation? So, the formula is slightly changed and it is the square root of summation fd square by n minus summation fd by n whole square into I, where all the values or all the terms they are having their corresponding meaning and significance, and I is a class interval and f is a frequency, d is a deviation, n is the total number of terms and etc. So, there is not much change in the formula, more or less the formula is similar, and now we have to tabulate the term, and here the age, the class interval and the mid value, the frequency and the deviation. In the same way, here is the average class and therefore 0 and minus 1 2 3 plus 1 2 3 d square fd and fd square, all the steps are more or less same. And now we have to put into the formula, and the standard deviation summation of fd square by n minus summation of fd by n whole square into I. So, if we are substituting the values summation of fd square 2435 by 500 minus summation fd 635 by 500 square into I, and if we calculate, that is equal to 9 years. And therefore, my dear friends, the standard deviation of this data set is 9 years. That means, the age that is starting from 20 to 55, and therefore, on an average it is ranging on both side by 9 years. That is the standard deviation. That is the meaning of this term. And now, how to interpret the standard deviation? It is the most widely used and important measure of dispersion, and it is used in further treatments like ANOVA, t-test etc., and it takes all values into consideration, and these are all some interpretation. And as deviations are squared, it is highly sensitive to variation, because the square of the deviation, and therefore, the variation is squared, and the greater the value of standard deviation, the more scattered is the distribution, and these are all some interpretation. And what are the advantages of the standard deviation? It is rightly defined and its value is definite. It is based on all observations. It is amenable to further statistical treatment and possesses many mathematical treatment, and squaring of the deviation make them positive. So, there is no question of negative. So, these are all the advantages. Now, let us have a short break. Welcome back. Let us continue. And now, what are the limitations of standard deviation? It is not easy to calculate. The calculation is a little bit tedious, and it is sensitive to extreme values than the values near the mean, because the deviations are squared, and therefore, the extreme values, they are causing more deviation to the standard deviation than the values which are very near to the mean. And so, these are all some limitations of the standard deviation. And now, let us take another concept called the quartile deviation. It is also measuring the dispersion. Now, let us consider the data set. Let us divide the total frequency into 4 equal parts, and the values which divide the frequency into 4 equal parts are represented by Q1, Q2 and Q3, and they are called the quartile. See, for example, if you take the continuum data, something like that, and the frequency distribution, that is taken in the axis, and if you are dividing that into 4 equal parts, the frequency distribution, and therefore, it is the first quartile, the second quartile, the third and the fourth quartile, and therefore, the total frequency distribution is divided into 4 equal parts, and that we call as quartiles. And now, let us define the quartile deviation. The value which divides the lower half of the frequency distribution into 2 equal parts is called the lower quartile. That means, suppose if it is a frequency distribution and it is we are dividing that into 4 equal parts, that is first, second, third and fourth, and the point which is dividing the first half into 2 equal portion, that means this particular point is called the first quartile or Q1. In the same way, it is the second half, and so definitely some point will divide that also into 2 equal parts, and therefore, that point is called the third quartile. That means, it is the first quartile and the third quartile. If the frequency distribution, that is symmetric, naturally, if we are dividing the first quartile and the third quartile into 2, exactly the median will be sitting at the midpoint. And therefore, now that we are clear about the first quartile and the third quartile, they are Q1 and Q2, and the difference between Q3 and Q1 is called the interquartile range. That means, if this is Q1, this is Q3, and the difference between Q3 and Q1. So, if this difference, that is called the interquartile range, and if we are dividing that the midpoint of the interquartile range, that is called the quartile deviation. So, the interquartile range, that is Q3 minus Q1, the midpoint of the interquartile range is called the semi-interquartile range or the quartile deviation. So, by formula, Q is defined as Q3 minus Q1 by 2. And now, we are going to calculate the quartile deviation. So, let us take a data set. In a symmetrical series, the median lies halfway on the scale from Q1 to Q3, and that means the median is equal to Q1 plus the quartile deviation. And now, let us take a data set and we are going to calculate the quartile deviation. So, the scores are like that, and their frequency and the cumulative frequency. And now, the formula Q1 is equal to L plus n by 4 minus Cf by f into I, and the terms are having their usual meaning, and n is the total number of terms, and therefore, n by 4, that is equal to 204 by 4, that is 51th item, and therefore, that is included in the class interval 20 to 30, and therefore, the 51th item, that is somewhere here, and that is in the class interval 20 to 30, and therefore, the lower point of that class interval is L, and therefore, this L is the lower point of that class interval, which is containing the first quartile, and therefore, here the L is 20, and here n by 4, that is 204 by 4, and minus the cumulative frequency of that particular class. Therefore, the cumulative frequency of the class which is preceding to that quartile deviation, the first quartile class, and therefore, that is equal to 29 and divided by the frequency of that particular class, that is 25, and if you are putting all the value into I is a class interval. So, again let me repeat, L is the lower point of the class interval which is having the first quartile, n is the total number of items, and Cf the cumulative frequency of the class prior to that first quartile class, f is a frequency and I is a class interval, and therefore, if you put all the values, that we are getting the first quartile as 28.8, and that means we have calculated the first quartile at the value 28.8. And you can check it also, because as we have already seen, the point is somewhat 51, that is from 20 to 30, that means it is exactly 28.8. Now, similarly, we have to calculate the third quartile. The formula is more or less same, and here instead of n by 4, we have to put 3 n by 4, and all other terms are having similar meaning. L is the lower point of the class which is having the third quartile, and the cumulative frequency of the class preceding to the third quartile class interval, and therefore, here 153rd item is included in 60 to 70, and therefore, the third quartile that is somewhere in this class interval. And now, by applying the formula, what we are finding out, the Q3 is equal to 63.63, and therefore, my dear friends, we have calculated the third quartile as 63.63, the first quartile 28.8, and therefore, the difference between these two, that is 34.84, that is called the interquartile range, and if you divide by 2, that is equal to the quartile deviation. And so, by using this formula, we can find out the quartile deviation. And now, what are the interpretation of quartile deviation? Quartile deviation is an index of dispersion. If Q is more, the dispersion is more. In a symmetrical distribution, Q1 plus Q or Q3 minus Q yields the median, but in a moderately asymmetrical series, Q1 plus Q or Q3 minus Q will not give you the median. So, that is depicted here. It is the median, and it is third quartile, it is first quartile, and therefore, the difference between this, so this point to this point, that is called the interquartile range. If you divide by 2, that is called the quartile deviation. And now, what are the merits of quartile deviation? It is simple to calculate and easy to understand. See, you look at the diagram, it is easy to understand, and it is not affected by the asymmetrical extreme items. So, these are all some merits, and in highly skewed or asymmetrical series, it is a better measure of dispersion than the mean deviation or standard deviation, because in standard deviation that we are squaring it, and therefore, the extreme values are affecting it very seriously, and that is not the case in quartile deviation. And it is useful in studying the dispersion in open-ended series, and it has some limitations also. It is not based on all the observations of the data, as it ignores the first 25% and the last 25% of the items. It cannot be treated further, as it is simply a positional measure, and if there are changes in the sample, it is considerably affected. So, these are all some limitations, and today we have discussed in this episode the definition of standard deviation, quartile deviation, and we had dealt with the calculation of standard deviation, quartile deviation, and we had interpreted the standard deviation and the quartile deviation. We discussed the uses, the advantages and the disadvantages of standard deviation and quartile deviation. So, today we had discussed 2 points of dispersion, the quartile deviation and the standard deviation. Now, let us have some questions. The first question, define standard deviation. The second question, why standard deviation is considered a better index of variation. The third question, write 2 advantages of standard deviation. The fourth one, in a symmetric distribution, what does Q1 plus Q or Q3 minus Q yields? And the last question, write 2 limitations of quartile deviation. So, with that